Today, we're going to break down the entire flow of data in ASP.NET Core MVC applications. We'll cover the roles of middleware, model entities, the repository pattern, entity framework, services, dependency injection, and how routing fits into middleware. If you've been wondering how everything fits together, stay tuned, we've got a lot to cover. Before we get into the details, let's quickly revisit the MVC architecture. In MVC, we have model, this represents your data. View, what the user sees. Controller, the part that handles the logic and interacts with the model to pass data to the view. This forms the core structure of an MVC application. But, in reality, applications are more complex, and that's where middleware, entity framework, repositories, services, dependency injection, and routing come in. Let's break it down. Let's start with middleware. Think of middleware as the gatekeeper in your application. Every time an HTTP request comes into your application, it passes through a series of middleware components before reaching the controller. Middleware can authenticate users, log request details, handle errors globally, redirect unauthorized users, route requests to the appropriate controller actions. Here's an example, say someone tries to access a restricted page. Middleware can check if the user is logged in before allowing the request to proceed to the controller. If not, it redirects them back to the login page. The router component of middleware is what maps the incoming request URL to the correct controller action based on defined routes. Next up is Entity Framework. This is our ORM or Object Relational Mapper, and it's what lets us communicate with the database without writing SQL queries. When you fetch data, Entity Framework retrieves the rows from the database and maps them into model entities, which are C# objects representing your database tables. Similarly, when saving data, Entity Framework converts those model entities back into SQL commands and updates the database. It's powerful and makes working with databases much easier. So, what exactly are model entities? These are classes that represent your database tables, like user, order, or product. When data is retrieved or saved, Entity Framework handles the conversion between database rows and these model entities. Think of them as the data holders that your application interacts with. Now, let's introduce DTOs, or Data Transfer Objects. DTOs are simple objects that are used to transfer data between the different layers of an application. They often contain no business logic, only properties. For example, if you have a user entity that includes sensitive information, you can create a user DTO that contains only the necessary fields like username and email. This allows you to control what data is exposed through your APIs and keeps sensitive data secure. Using DTOs can help optimize data transfer, reduce the amount of data sent over the network, and decouple your internal models from the data exposed to the client. Now, let's talk about the repository pattern. Repositories add an additional layer between the controller and entity framework. Without a repository, the controller would directly interact with Entity Framework to retrieve or save data. But if you use a repository, you separate your data access logic into a dedicated class, for example, User Repository. The repository is optional, but it's often used to keep your code clean, flexible, and easier to test. Services are another important part of the architecture. While controllers handle requests and responses, services are used to handle complex business logic. For instance, in an e-commerce application, when a user places an order, multiple things need to happen: updating the inventory, sending confirmation emails, and maybe even processing a payment. Rather than cluttering your controller with all of this logic, you can offload it to a dedicated order service. The controller will then call something like orderService.placeOrder, and the service will handle the rest. Before we dive into the data flow, let's discuss dependency injection, or DI. This is a crucial pattern in ASP.NET Core that helps manage the dependencies between your classes, promoting loose coupling. When you set up your application, you register your services and repositories in the startup.cs file. For example, if your order service depends on an order repository, you define this relationship in the constructor of order service. The benefits of using DI include loose coupling. Your classes aren't responsible for creating their own instances, making your code modular and easier to maintain. Testability, you can easily swap out implementations for testing. For example, using a mock repository during unit testing is straightforward with DI. ASP.NET Core's DI container automatically resolves these dependencies, allowing for cleaner and more maintainable code. Now that we've covered the building blocks, let's look at the full data flow through this architecture, step by step. View, a user submits a form on the website. Middleware, the HTTP request passes through middleware, which could check the user's authentication status or log the request details. The router also determines which controller action to call based on the request URL. Controller, if the request is valid, the controller processes it and might delegate tasks to a service. Service, the service handles any business logic, like checking inventory or sending a notification. Repository, optional, the service could use a repository to retrieve or save data, adding a layer of abstraction over data access. Entity framework, if the repository or service interacts with the database, Entity Framework converts the model entities to SQL commands. Database, finally, data is saved to or retrieved from the database. Now, the big question, why use middleware, repository, and services? Middleware, it helps you control and monitor every request coming into your application, perfect for things like authentication, logging, and error handling. The router also streamlines the request handling process by directing traffic to the correct controller action. Repository pattern, it adds a layer of separation between your controllers and data access logic, making your code more organized and testable. Services, these help keep your controllers clean and focused on handling user requests by offloading business logic. Dependency injection, it promotes loose coupling and enhances testability, making your application easier to manage. DTOs, they provide a way to transfer data cleanly and efficiently, while protecting your internal models from external exposure. You don't always need to use all these layers in every project. For small apps, you might skip the repository or services and just work directly with Entity Framework in your controller. But as your application grows, these patterns help you keep your code clean, organized, and scalable. If you found this video helpful, hit the like button, subscribe to the channel for more developer content, and don't forget to ring the bell icon for notifications. Thanks for watching, and I'll see you in the next video.